Hi, so we are going to talk about Bernoulli's equation. Bernoulli's equation is of the form dy over dx plus p of x times y equals q of x times y raised to n. So this n here represents an integer. Okay, so what makes this equation distinct from linear is that the presence of y raised to n. So if you remove this y raised to n in this equation, so this will be linear in y. Okay, now how do we solve Bernoulli's equation? So we're going to transform this into a linear form. Okay, so we first remove y raised to n. So we divide the entire equation by y raised to n or multiply this by y raised to minus n. Okay, so this will become y raised to negative n dy over dx plus, so you copy p of x, y times y raised to negative n is y raised to 1 minus n equals q of x, and this will be canceled. So you have a pure function of x on the right hand side of the equation. So now the next step is to introduce a new variable. So we are going to replace y raised to 1 minus n by a new variable. So say letter z. Okay, let z equal to y raised to 1 minus n. Since we are going to replace the variable y by this new variable, so we are going to also replace its differential. So dz is equal to 1 minus n times y raised to, so 1 minus n minus 1 will become y raised to negative n or minus n times dy. So going back to this equation, you can see y raised to negative n dy. We are going to replace this one. So we are going to rearrange this equation here, dividing then both sides of the equation by 1 minus n. So we have dz over 1 minus n is equal to y raised to negative n dy. Okay, now we are going to replace this equation by, so you have 1 over 1 minus n, okay, times dz over dx plus p as a function of x, and then replace this by the new variable z equals q of x. Okay, now that we have the variables z and x in the equation, so we are to put this equation into linear or into standard form. Okay, so that's how we solve linear equation, to put the equation into standard form. Okay, so we should remove this coefficient here. We then multiply the entire equation by 1 minus n. Okay, so we have dz over dx plus, okay, multiply by this one, so 1 minus n times p of x times z equal to q of x times 1 minus n, or you can put 1 minus n first since this is an integer or a constant. So 1 minus n times q of x. So this equation now is um, a first order linear equation. So this is linear in the variable z. Okay. Okay, that's how. So once you put the equation into standard form, you determine the integrating factor, and then, of course, you introduce that into that standard form. And afterwards, the equation will become an exact equation, and you should, follow the steps or the shorthand method in finding for the solution of an exact equation. Okay, so let's solve an example problem. Okay, now let's solve this example. Solve dy over dx plus 3y over x equal to x raised to 4 times y raised to 3. Okay, as you can see, this equation is now in Bernoulli's form. And what we will do is we transform this into linear or equation or to linear form. So the first thing is that, as you can see, the right-hand side of the equation contains variables x and y. So we need to eliminate the function y at the right-hand side of the equation. So first, so dy over dx plus 3 over x times y equals x raised to 4 times y raised to 3. So to eliminate y raised to 3 here on the right-hand side, so we multiply both sides of the equation by y raised to negative 3, or basically we divide the entire equation by y raised to 3. Okay, now we have y raised to minus 3 dy over dx plus, so this becomes 3 over x, y times y raised to negative 3, this will become y raised to minus 2 equals x raised to 4. So we were able to eliminate y raised to 3 on the right-hand side of the equation. Now the next step is that we're going to introduce a new variable. So let z equal to this function here, y raised to negative 2. And then we differentiate, so dz equals minus 2 y raised to, this becomes, so minus 2 minus 1 is minus 3 dy. So you can see this expression here in our equation. Now we put this into this format by, okay, we divide both sides of the equation by negative 2. So we have negative 1 half times dz equals y raised to minus 3 dy. Now we plug in here these values. So we have negative 1 half dz over dx. Okay, the second term we have plus 3 over x. This becomes z equals x raised to 4. Okay, now we arrange this equation into standard form. Okay, this is actually linear in terms of z. Now we should make the first term. Of course, the coefficient should be 1, so we eliminate 1 half there. We multiply both sides of the equation by negative 2. That's why we have dz over dx plus, so yeah, negative 2 times 3. So you have negative 6. So you put actually minus 6, okay, over x times z equals negative 2 x raised to 4. Okay, now this is in standard form. So as you can see, our p of x here is equal to negative 6 over x, and our q of x is equal to minus 2 x raised to 4. Now I have actually written p of x and the q of x here for me to be able to, or to easily, determine, okay, what to utilize in finding for the integrating factor. So we know that the integrating factor is e raised to the integral of p of x times d of x. Okay, that's why I have written here my p of x. So the next step is to solve the integrating factor. So e raised to, we have minus 6 over x. So you factor out minus 6. So minus 6 integral of dx over x. Thus we have e raised to negative 6 ln of x. Okay, we can simplify this one. We put it in form that we can simplify. So e raised to ln of x. So the argument will have a minus 6 exponent here. So e raised to ln of something is equal to something. So this now becomes x raised to negative 6. So our integrating factor is x raised to negative 6. We now multiply this standard form by an integrating factor. So x raised to negative 6 times dz over dx minus 6z over x equals minus 2x raised to 4. So this part of the equation is solving for a linear equation. Now we have a technique in solving for a linear equation. Okay, we know that the left-hand side of the equation should always be equal to the integrating factor. Okay, if you are to integrate this one, okay, we know that once you multiply the standard form by this integrating factor, this becomes an exact equation. Okay, so the left-hand side will be equal to the integrating factor x raised to minus 6 times the dependent variable, which is z. So times z equals, the right-hand side will be, of course, your q of x, which is minus 2x raised to 4 times the integrating factor. So x raised to minus 6 times dx plus the constant of integration. So plus c. Now, you need not integrate, the left-hand side of the equation because this is already the answer. Now, your concern is to integrate this one at the right-hand side of the equation. So we simplify first. So this becomes, you factor out minus 2, or you put negative 2 before the integral symbol, and x raised to 4 times x raised to minus 6. This is x raised to minus 2 times dx plus c. Okay, just copy the left-hand side of the equation. Okay, now we try to erase this one and continue our solution. Okay, I hope I will not be able to. Now we copy. So x raised to minus 6 times z equals, okay, minus 2. The integral of x raised to minus 2 dx is x raised to negative 1 over negative 1 by power formula. Okay, and then plus c. So the right-hand side will be negative 2 times negative. This is positive, and this becomes 2 over x plus c. Okay, now z is not the original variable, so yeah, but z is equal to y raised to negative 2. So you plug it in here, x raised to negative 6. Okay, so you have y raised to negative 2 equals 2 over x plus c. Okay, so this is now the general solution. You can arrange this equation. Okay, try to, you know, write your answer without negative exponents. So you can put this in a form 1 over x raised to 6 times y squared equals 2 over x plus c. Okay, so this is your final answer. And if you're asked to solve for y, for the dependent variable, so we can do that. Okay, let me erase this one. Okay, if you're asked to solve for y, so this will become, okay, 1 over x raised to 6. Okay, we copy first, y squared equals, so we put it in to one fraction, so that will be 2 plus cx over x. And then we cross multiply. Okay, so this becomes 1 over x raised to 6 times this one, 2 plus cx over x. Okay, I hope you can follow this one. And then this will be y squared. All right, so we can simplify this one, cancel one of the x's there, so x raised to 5 will remain. And we have, okay, take the square root of both sides, so y is equal to, okay, the square root of 1 over x raised to 5 times 2 plus c times x. Okay, this is your final answer. and solving for y. So either of the two will be okay. So thank you.